All right, we're in section 15. And again, it's on the related stage code. Let me just, go through this and see how I can do it. All right, so let me just scroll this up a little bit. Reset, we've been doing this for some time now, right? I'm going to define x as a variable. And then I'm going to define a function y of x. What's y of x? It's being assigned 1 over 1 minus x. Okay. Now, what do they want to do? They want to differentiate y of x with respect to x. But now with the 2 over here, what they're saying is something. And let's just see what it gives us back, and then we'll discuss what it's saying. Now, I'm going to say, looking at that, what it's saying is it's saying take the second derivative. So let me just type in 1, and it gives me this. Let me type in 2, and it gives me that. Now, someone's going to say, could you keep playing this game as long as you like? I got to be honest with you, there is a pattern to this. You may not know what the pattern to it is, but there is a pattern. Now, the simplest pattern I see over here is the bottom. And what am I seeing? Well, the bottom is, again, when I say that, the bottom, it's x minus 1 to a power. And certainly if I look at the first one, derivative 2, it gives me a power of 3 in the bottom. Now, if it's 1, it's going to be 1 over, I know that's minus 2 over there. It's 1 over 1 minus x squared. Then for 2, it's x minus 1 cubed on bottom, x minus 1 4 on bottom for 3, so forth and so on. Now, I'm going to say, if I want the 6, I definitely could tell you what the bottom is going to be if there is a pattern to it. What should the bottom be? X minus 1 to the 7th power. Good. Let me try something really crazy, like 100. This might get scary. Wow, that's scary. What's the bottom? No, as expected, x minus 1 to the 101st power. All right, let's try another one. Let's try, I don't know, 40. What am I expecting to see? X minus 1 to the 41st power on the bottom, and I'm seeing it. So I definitely got the bottom covered. It's the top that's trouble. What am I noticing it? And again, just looking at it, the 1 would give me a 1 on top, a 2 would give me minus 2. 3 would give me 6. 4 gives me minus 24. 5 gives me 120. 6 gives me minus 720. So I'm going to say over there, I know it alternates between plus and minus, but what are those numbers? Now, granted, I am not saying that you know what those numbers are, but those numbers are actually factorial. For example, if I do 6 factorial, what's 6 factorial? 6 times 5 times 4 times 3 times 2 times 1. Oops. That's 720. So this is 6 factorial. I know there's a sign error. What's 5 factorial? 120. 4 factorial is 24, so forth and so on. So there's really a nice pattern to these problems over here. Really nice pattern. All right. Well, that's part of it, seeing a pattern. All right. I'm wondering where that question came from, though. So I'm going to just scroll back over the notes. And were they ever asking me to differentiate 1 over 1 minus x repeatedly? All right. Let's talk about that. Were they ever asking me to do that repeatedly? And some of it is really annoying to scroll back over. You need to start to learn to study. And that means you're constantly looking back over your notes, constantly looking over your notes. All right. It is painful sometimes, especially if you're not getting it. To keep looking back over something and not getting it, it's super painful. All right. But anyways, it's this one over here. All right. Y prime. And I think for the most part, and I do that. Yeah, double. Yeah, I think I did that. Nice pattern to it, though. All right. I want to scroll back over the notes, though, and I want to look at maybe something that we haven't done. I can keep scrolling. Don't be discouraged. Now I'm looking at this. I'm just scrolling through the notes. Yeah, 13 looks interesting. I guess we could do that. Let's try 14. I'll read it to you. It says let f of x equal that. Let me clear the screen up there because it's really annoying to look at all that typing. So I'm going to say f of x is x, whoops, x plus 4. Remember, you might be disappointed by using a machine because it doesn't give you what you want. And what you want is you want something that simplifies your life. But this one says use a computer algebra system. Well, I'm going to define f of x. So what I want to do is I want to start looking at derivatives. And I think I remember. So differentiate f of x, comma x, and I want the first derivative. All right. So I'm seeing this over here. Let me see if I got the right one there. And let me see. Well, I'm really not seeing this one, am I? It is really tough looking, isn't it? Let's see what I can see over here. You know what? I think I am seeing it. And let me go back over here. And I'm seeing the minus. This is 4 plus x, but they got x plus 4, x minus 2 squared. And then I see the 1 over. Oh, yeah, I am seeing it. Let me go 2. Let me see if I can do the second one, see if I can see that one. I want to see if I see that one too. Well, I'm seeing minus 2 over x minus, well, I'm seeing the first term. And let me see if I'm seeing the second term. That would be 2. Yeah, I'm seeing that one too. Wow, this is a miracle. I'm starting to see things, aren't I? Now, this is where a piece of paper and pencil might come in handy. That if you're writing these things down, if you're looking at a computer screen, though, you might say, I don't know what the hell I'm looking at. Let's try the next one, see if we're getting that one. Whoops, I didn't finish that one off, right? Third derivative. Let's see. I'm seeing the 6. Yeah, I'm seeing that one. Might be a different order, by the way. I'm seeing that one too. Let's try 4. You know, this machine does it really quickly, by the way. Let's see if we're getting this one. Let's see, minus 24. Yep, I'm seeing that. And I'm seeing the other one. Yeah, I'm seeing that too. All right. Okay, let me repeat this. It is so important that you write things on paper in a nice, neat way. All right, I'm going to claim that I looked at my computer algebra system and I'm agreeing with what's being stated over here. I'm agreeing with it. Now, my hope is this. I really mean this. My hope is that you can see a pattern to these problems over here. And I want to point out, I'm looking at it. If I wrote this down neatly and looking at it, I would definitely be writing down what I'm seeing over here. All right. I would try to write it really neatly. So I'm definitely seeing like the first term is 1 over x minus 27 to some power each time. First derivative, first power. Second derivative, second power. I'm just looking at the first term. What I mean by that, this 1 over x minus 27 to a power. That's easy to predict on. But what I say for the kth derivative, 1 over x minus 27 to the kth power, just by looking at that first term. I'm counting one rabbit at a time. Next up, I definitely see a subtraction symbol between these guys. I'm going to predict minus. I'm definitely seeing 4 plus x every single time. I'm definitely seeing x minus 27 to some power on the bottom every single time. What's changing is the power. The first derivative gives me a power of 2. Second derivative gives me a power of 3. Third derivative, 4. Fourth derivative, 5. What would the kth one be? K plus 1. All right, I got the outside now. This can get tough. 1 minus 2, 6 minus 24. They're factorials. No doubt about it. We'll do sign later. 1 factorial, 2 factorial, 3 factorial, 4 factorial. What would I get over here? K factorial. Seems to make reasonable sense. Powers. The way I like to do powers is I like to take the number -1 and raise it to something. This is positive and negative, positive, negative. It alternates. So let's try it. Took -1 to the first power, I get -1. That's not a good idea. So I would take -1, and then I would say first derivative +1, which would be K +1 now. Well, when I send over there, it alternates back and forth. For example, if K is 1, you get 1 + 1, which is 2, -1 squared is positive. If you took K to be 2, you get an odd power here, you get negative, so forth and so on. So this is a really easy thing. Let me repeat this though. When you're using a computer algebra system, it is in your interest to write down what the derivatives look like. I want to go to one other system now. All right. And I'm going to talk about that now. I'm going to talk about Wolfram Alpha. I'm not saying this is going to work for you either. You don't know what works for you until you try things. So I'm going to go to Wolfram Alpha. That's Wolfram, WOLFRAMALPHA, wolframalpha.com. And what I want to do is I want to type in, I want to differentiate. Let's see, x + 4 divide by x - 27. And by the way, I don't really, I'm not a big fan of using Wolfram Alpha, but a lot of people are. They think this is the best thing possible. I want to warn you about this, though. I'm going to differentiate this with respect to x. And let's see how I did over there. First of all, I type it in right. See, I got this over here, didn't I? Twice. Let's see if it understands it. Nah, it didn't understand it. This is why I don't like it that much. So I'm going to say, take the second derivative of. Yeah, it understood that, by the way. As soon as I really, I'm having a tough time with this, and you might be, but I'm wondering, did I get the same answer? Well, I factored out the 2 because it really annoyed me, and I'm getting the same answer. Yep, getting the same answer. Now let's say take the third derivative. And you notice I got to play around with this. I don't know if it's going to be able to understand what I just wrote down. It did. And it's agreeing with it. Let's say I want the fourth derivative. It did it. Let's say I want it. I'm going to type in the kth. I don't know if it's going to understand me, by the way. Really doesn't, does it? No, it didn't understand me. That's not good. So the deal about this over here is that you got to play around with tools and see which one works for you. All right. What do I like? I like using Sage. You might like Wolfram Alpha. You like it Mathematica. It's entirely up to you what you want to use. All right. To learn. You want to learn. I really emphasize that enough times. You want to learn.